All right, welcome back. Today's topic is going to be using trigonometry ratios, or our trig ratios. So I'm sure you're wondering, like, great, I went through and I was able to identify that the sine of angle C was 7/15. How does that help me? Well, it does this pretty amazing thing. What it does is it allows us to be able to find the side length of a right triangle when you're only given one acute angle and one side length of the triangle. So, Pythagorean theorem requires us to have two sides of the right triangle. Trigonometry just means that we need to have an acute angle and one side of the right triangle, and then we can find another side of the right triangle using trig, and then we can use the Pythagorean theorem if we want to. So, however, before we do all of that, we have to make sure that we have our calculator in the right mode. So some of you might have just a regular scientific calculator, and you'll notice there's a degree button up here, DRG. You want to make sure that the DRG is underlined. Make sure that it's not in radians or gradians. We want to make sure that the mode is in degree mode. One of the easiest things, if you're not really sure how to fix your calculator or what mode it's in, is you can actually reset your whole calculator. You can just do second 0, reset. Yep, let's reset it. The memory is cleared, and you'll notice down here in this corner it says DEG. It's going to default back to degree. In a graphing calculator, you also want to make sure that your calculator is in degree mode. Now, degree mode is not the normal for calculators, scientific calculators. Your scientific calculator likes to default to radian mode. You can see radian is above the flashing cursor right now. You want to make sure that you go to that and you highlight degree so that the degree is actually highlighted. And then once you've highlighted that, you can quit out of this mode. And now you're in the right mode. So I'm going to use this calculator, but I'll get the same answer that I would if I was using my other calculator. And all we want to do is just practice finding these values. So what does this mean? This says the sine of 20 degrees. Well, remember, the sine ratio was equal to the length opposite that angle divided by the hypotenuse. That's what the sine ratio said, right? The sine of an angle is equal to the length of the side opposite divided by the length of the hypotenuse. So what this means is it means I have a right triangle with a 20-degree angle. And somebody took the time to make all these different sized triangles right triangles with a 20-degree reference angle, and they measured the relationship between the side opposite and the hypotenuse. And they found that when I had a 20-degree angle, the side opposite from that angle divided by the hypotenuse came out to be this constant number. That's the number that shows up on your calculator. So when I input the sine of 20 degrees in my calculator, I get this crazy decimal. We want to take this decimal to 4 decimal places, so 0.3420. And what this number represents, it represents a constant ratio of the side length opposite the 20-degree angle divided by the hypotenuse. We'll always divide to this number. It's crazy if you think about it. Somebody drew like a bazillion of these triangles in the sand and found out that these ratios were all the same and created this trig table that we're still using today. So all you're going to do up here is just practice inputting into your calculator. So the cosine of 20 degrees gives us 0.93969, so let's do 0.9397. We can round that up. And again, this is the ratio of the adjacent side divided by the hypotenuse when your reference angle is 20. And then the last one is the tangent ratio, 0.3639. So we could probably say 0.3640. All right. So now that we've been able to input into our calculator, and I'll give you some time, now would be a great time to pause the video and finish the rest of these. Now let's actually use it. How is this going to help us? Let's see the magic that happens here. So here we go. Notice that we're given our reference angle. That's 72 degrees. Just like we did in the previous lesson, we want to label the hypotenuse We want to label the adjacent side and we want to label the opposite side. Notice in this particular example that we don't have any information for the adjacent side. So I'm going to cross that off. I don't need that one. So now you want to ask yourself, okay, what trig ratio compares the opposite side with the hypotenuse? And maybe it's worth just rewriting these up here. What ratio compares the opposite side and the hypotenuse? Well, that's the sine ratio. Now, we're given an acute angle here at 72 degrees. So watch what happens. We're going to create an equation. And that equation is going to look like this. The opposite divided by hypotenuse ratio is the sine ratio. So we're going to say, okay, the sine of 72 degrees is equal to the opposite side, which is represented by x, divided by the hypotenuse, which is 18. And now what we want to do is we want to solve this equation for x. Well, x is currently being divided by 18. So because it's being divided by 18, I can multiply both sides by 18. And what happens is 18 divided by 18 is 1, and essentially they cancel out. And what we're left with is 18 times the sine of 72 degrees equals x. And depending on the type of calculator that you have, we can just input all of this in here. 18 times the sine of 72, and that gives me an answer of 17.119. And in the directions, it's asking me to round to the nearest tenth. So I'm going to say this is equal to 17.1. And what you just found is that the side length opposite a 72-degree angle in a right triangle that has a hypotenuse of 18 is approximately 17.1. I'll give you a moment to kind of digest that a little bit. All right. Let's take a look at the next one. The next one, again, here's our reference angle, 72 degrees. My hypotenuse is this one right here. My hypotenuse and my adjacent create that reference angle. That means that this side is the opposite. Now, in this particular example, I have no information given to me on the opposite side. So what's the ratio that compares the adjacent and the hypotenuse? Right, it's the cosine. So now that we know what ratio to use, let's write out our equation. The cosine of 72 degrees is equal to the adjacent side over the hypotenuse. And there's my dog. Hang on a moment. Okay, now we have our equation. The cosine of 72 degrees equals x over 11. So the adjacent side divided by the hypotenuse. And again, in order to remove the 11 from the denominator, we'll multiply both sides by it. And what we're left with is 11 times the cosine of 72 degrees equals x. Now, you can always just figure out what the cosine of 72 degrees is. Some of us might have to, depending on the type of calculator that we have. And then multiplying that by 11. That works just fine. Or you can do 11 cosine 72. And notice that we get the exact same answer. So in this situation, our final answer is 3.4. That's the length of our adjacent side, and we're good to go. I'll leave this last one for you, but you can probably guess that it's going to be the tangent ratio because that's the only one we haven't done yet. So what happens when our variable is in the denominator? So let's take a look at an example where that might happen. Let's take a look at example 15 here. In example 15, we have our reference angle, which is 49 degrees. This is our hypotenuse because it's the side opposite the right angle. This is our adjacent side. Whoops. Our adjacent side. because the adjacent and the hypotenuse create that right angle, which means this is opposite. Which is the side length that has no information on it, no variable, no number? That's the hypotenuse. Cross it off. What ratio compares the opposite and the adjacent? It happens to be the tangent ratio. So let's set this one up. We have the tangent of 49 degrees equals the opposite side, which is 14, over the adjacent side, which is x. Notice that the variable is now in the denominator. So mathematically, what we can do is it's kind of like a two-step process. I'll show you what to do mathematically, and then I'll show you what the shortcut is. Well, in order to get the x by itself, or at least out of the denominator, I would have to multiply both sides by x. And now I'm left with x times the tangent of 49 degrees equals 14. I still want to get x by itself, so that means I need to divide both sides by the tangent of 49 degrees. And I didn't give myself enough space, so I'll continue over here. So right now what I have is x equals 14 divided by the tangent of 49 degrees. So look at what happened between the green one and this one. The x and the tangent of 49 degrees changed places. So now on my calculator, if I want to figure out what that value of x is, I can just take 14 and divide it by the tangent of 49 degrees. And that gives me approximately 12.2. So in the previous examples that we had done, our variable was in the top. The most common question that I get is, well, how do I know if the variable is in the top or the bottom? And that is one of those geometry conundrums. It all depends on the information that you're given. So you really have to pay attention to what you're given, opposite adjacent, opposite hypotenuse, and which one has the variable in it. Is it the opposite side that has the variable, the adjacent, or the hypotenuse? That's going to depend on where your value of x goes. So that's it for now. I will post these to the classroom, and of course I'm available during our office hours to help. And I hope you have fun with Trig, because it's one of my favorite things. Talk to you soon. Bye.